This is part 6, integrating outdoor air with building pressure control. We've talked about dilution ventilation, we've talked about pressurization flow. Now we need to really integrate them together so that we can actually control them. And so we're going to look at what our airflow control points need to be. We're going to start by looking at our outdoor air. And our outdoor air is really driven by our dilution ventilation requirements for IAQ or our economizer free cooling requirements. When we look at pressurization, it's all about the pressurization flow like we talked about. And basically, if the pressurization flow is greater than 0, then our pressure zone net pressure is positive. And if it's less than 0, it's net negative. All right. And so when we take a look at this pressurization flow calculation, which is really based on the ins and the outs, the outdoor air is kind of driven by what we need for dilution ventilation or economizer, as is the exhaust. The exhaust flow rates are driven by what the toilet exhaust requirements are, or whatever our local exhaust requirements are. So what that leaves us is the relief air, okay? And that's the path that we're going to want to control. However, you're going to find that it makes more sense to control that differential between the outdoor air and the relief air paths, which in IP units here in the States, we're going to call delta CFM because we're measuring in cubic feet per minute. So that's what we want to control, is we're going to this delta CFM differential. All right, we're going to take a look at supply and return fan systems first. All right, so in a supply and return air fan system, for dilution ventilation, we're going to put an airflow meter in the minimum outdoor airflow path. All right, it may be the complete outdoor airflow path, or it may just be the minimum airflow path, depending on what the flow rates are. And I always tell people, try to select an air handling unit where the minimum flows don't go below 150 feet per minute. You know, you may have a louver velocity that's lower than that, but some air handlers kind of transition to higher flows. That way you're not going to have this wind problem that we can see where as the wind blows and transient wind gusts actually will false out an airflow meter. And it's not a limitation of the airflow meter. Our flow meters will measure accurately down to still air. But if you get the velocities too low and you have wind gusts, you'll get these false readings, and you really don't want to see that. And never mind the fact that you can't really control 30 or 40 feet per minute across a damper. On a custom air handler, you might just go min-max, but on some of your package stuff, you really don't have much of a choice. When there's no relief at the air handler, that basically implies that your pressurization requirement and your dilution ventilation requirements are the same. And when you do that, what we want you to do is use the outdoor airflow station. Even if the outdoor airflow station was 5 or 10% of reading accurate in this location, it's better than looking at, say, the supply and return differentials, as we talked about in previous presentations. All right. When you get relief at the air handler, what we had talked about just a couple slides back was, hey, you know, you want to maintain this outdoor air relief air differential. And although that is true, you're going to find that on most air handling units, there's not enough good locations to measure on most of these to get accurate enough measurement for differential flow control. So the outdoor air is marginal at best, and the relief air is often not even measurable, okay? And so but we still need that differential. So if you remember from our previous presentation, I'll just do it again, that when we looked at this one point here, and we saw that the recirc air and the outside air equal the supply air flows, and then we looked at this other point and saw that the recirc air and the relief air equal the return airflow. And if you subtracted those two equations, you still had an equation. You found that, hey, this differential that you want, the outdoor air minus the relief, is equal to the supply air minus the return air, even on these recirculating air systems. So really, that's where you want to measure, because those are better measurement locations. You're typically going to find a better location in the supply and return airflow paths. Keep in mind, you didn't have to be on that side of the fan. It's just anywhere in this path, all right? And the nice thing about this is this helps you on verification. We are not really talking about verification, but if you go to 100% closed loop, meaning you close the intake and the relief air dampers, and you can actually compare one flow meter to the other flow meter, and if one's in a marginal location, you can actually use one to tweak or adjust it to match the other. So it's a really good place to go, all right? And so ultimately you want these three measurement locations. And do keep in mind, there could have been energy recovery in here. We're just looking at the flow paths that we need to measure on these recirculating air handling systems. I will also say to you that I would use the same measurement locations on a supply relief fan system if the relief fan is located in the air handling unit. I have different slides if you have a supply fan with a separate relief, and I'm not going to be able to get into that today. All right, so I have pretty good slides on the actual sequence of operations, but I don't have enough time to do them in this short version of this presentation. So if you need to know more about the actual sequencing I'm going to discuss, because I'm just going to call it sequencing, I do have actual diagrams to show you what the proper sequence of operations would be. So we're just going to generalize here. And this first thing we're going to generalize on is what you don't want to do, okay? And I see a lot of people do this. So here we have our outside airflow meter and our supply and return airflow meters. And, basically what we want to do here is we want to control minimum outdoor air and our pressurization flow. And what I see a lot of people do is try to do this simultaneously. It isn't going to work. It's conflicting control loops. The difference between the supply and the return differential, although it's mathematically equal to what the outdoor airflow is going to be, we talked about instrumentation uncertainties and how they'll never be the same, so that makes your system hunt, all right? So you don't want to do that, all right? What you want to do is you want to use the outside airflow station, and if it's a supply and return fan, we have the added advantage. Most people look at the return fan as a disadvantage. I look at the return fan as an advantage in our sequence, that we actually can make the return fan our friend, okay, and use it as part of our sequence with the outside air intake damper and the recirculation air damper. We'll sequence them such that we maintain the outdoor airflow set point that we are desiring. And when we finally do have relief at the air handler, meaning in this case here, I'm not free cooling, I'm not an economizer. It's just that my outdoor air requirement exceeds that for building pressurization. Well, that's when the supply and the return airflow station are going to come into play. And so we're going to modulate the outdoor air and the recirculation air damper to maintain our minimum outdoor airflow set point. And we're going to maintain, control the return air fan to maintain the supply minus return differential. And again, if it was a supply relief fan system, we'd be doing the same thing. Now, the one thing that we do add on a supply return air fan system is, we can either go to two position on this relief air damper, which is one way to do it, or if we want more positive verification, we can put a pressure sensor across that relief air damper, or we'll use actually a bleed airflow sensor across it and control it that way. But it effectively makes it two position. When we're in economizer and we're free cooling, it's really no different than when we're in minimum outdoor air mode with relief. The biggest difference is we're not as concerned about the airflow rate. We're more concerned about the supply air temperature. And so the building pressure is still being maintained by the differential between the supply and return airflows. We're typically not that concerned about the outdoor airflow. We're not even necessarily using it as part of the control strategy. There are cases when we can be economizing at cold temperatures where we have to be cognizant of the reduction in the outdoor air flow rate, but I'm not going to really go into that right now. But everything pretty much is the same when we're doing economizing from a pressurization perspective. When we get into DoAs, or dedicated outdoor air, I don't think enough people are actually measuring and controlling DoAs properly. We'll start off with the most simple unit, okay? It could be a single or multi-zone system. Typically, but you're considering it to be one ventilation zone, okay? And this could most likely is energy recovery. It doesn't have to be energy recovery, but basically, at a bare minimum, you need to maintain that differential between the outdoor air and the exhaust air. And the reasons that you need to do it, basically, just what we talked about previously is is it could be wind pressure you're dealing with, it could be stack pressure you're dealing with. We talked about filter loading as a problem. Filter load's different on the intake and the exhaust side. And you're trying to recoup so much outdoor air that you don't have the pressurization air that you used to have. I've actually seen a lot of, particularly in schools in the Southeast, that have energy recovery, but they don't have, and DoAs, but they don't control these flows, and they don't look at these flows, and they get to the point where they're bringing in plenty of outdoor air, but the exhaust starts to exceed the intake, and we make these spaces negative. And I've gone into classrooms where the walls are soaking wet, and they have mold problems, and it's really a serious problem. In fact, down here in the Southeast, there's school districts that are actually being sued over this and mold problems. So something that you really need to be cognizant of, bare minimum, maintain this differential, and don't forget about the toilet exhaust system. When we get into DoAs and multiple ventilation zones, we really need to be measuring the airflow into each ventilation zone, okay? And in most cases, when we do multiple ventilation zones, we're at least going to have some kind of binary occupancy where that zone's going to go unoccupied. And, as soon as those zones start to go unoccupied and you start to shut down the outdoor air there, you're changing the amount of outdoor air that you're providing to all of the other ventilation zones. So you really need to be modulating them. And the big concern is as you're cutting back the outdoor air to these ventilation zones, if you're not paying attention to what you're doing on the exhaust side, you're going to drive the ventilation zones negative, and you're going to end up with this problem that I talked about bringing in humid outdoor air. So you got to be really careful here. So as a bare minimum, what I'd like to see you do is measure at the ventilation zone and track at the worst case, track at the DoAs unit, or at your at the exhaust side of this thing, right? Ideally, and I can't tell you that I get a lot of people to do this, but ideally, particularly in hot humid climates, you really should look at tracking the ventilation zone ins and outs on a DoAs system, all right? I think that's a better way to do it. It's just hard to get people convinced that they should spend the money to do it, but I think in the long run, it makes sense. That's the end of part 6. In part 7, we're going to be talking about making buildings safer during and after COVID-19. I'll see you in part 7.